right, this is microeconomics, and this is the first day, so we're going to be looking at the appendix to Chapter 2. All right, we've got different ways to graph data. As you can tell from the appendix, there are line graphs, there are pie charts, there are different ways to graph data, but the best way to represent data when you've got two variables, which is mainly what we're going to be working with in economics. So if we had x and y, for example, is a line graph. So if we had this data over here, so let's just say 1, 2, and 3, 1, 2, and 3. For x and y, here's how you would plot it. Now, usually we put x over here, if you remember from math, on the horizontal axis. And usually we put y over here on the vertical axis. 0, 0 is right over here in the corner, the origin. And on the horizontal axis, from left to right, the numbers get bigger. So here's 1, 2, and 3. And on the vertical axis, we've got 1, 2, and 3 numbers going up as we go up the vertical axis. So that first point, 1, 1, we're going to find where x is 1 and y is 1. That would represent this data point right here. The second data point is 2 and 2. And the third one is right there. And then if you connect those dots, you've got a line that looks like that. And when both variables are moving in the same direction, here, 1, 2, 3, that's what x is doing. And for y, it's doing the same thing, right? It's also increasing with 1, 2, 3. What do we call that? When two variables are moving in the same direction, what kind of relationship can we call that? Positive relationship. Excellent. Another word for that is a direct relationship. And I'll just write the definition for you. When two variables move in the same direction. All right, so there you've got the definition. You see what it looks like. Can you all, and I just have these two generic variables up here, x and y. But can you all think of any real-life examples of two variables that actually do move in the same direction?
The cost of living and gas go up.
All right. Yes. So the price of gasoline, the more you have to pay, the more your cost of living is going to increase. Sure. Maybe height and weight. Certainly for little children, as they're growing taller, they're going to be putting on some weight. All right, I think you all get the idea of what a positive or direct relationship looks like. Let's take a look at a negative relationship. All right, so we're going to put x and y back up here. And let's have x doing the same thing, 1, 2, and 3, and we'll have y doing the opposite, 3, 2, and 1. I'm going to draw my axes back up here in the corner. We'll put x again on the horizontal axis and y again here on the vertical axis. Zeros in the origin. First data point, x is 1 and y is 3. So we're going to find where x is 1 and y is 3. That would be represented by this point. 2 and 2 is right there. And then when x is 3 and y is 1, we're right there. And if you connect the dots, you can see the lines go in the opposite way, right? Before, with a positive relationship, it was sloping upward. Now it's sloping downward. And we already know that this is a negative relationship. Does anyone remember what another word for inverse? An inverse relationship. Okay, so this is a negative or inverse relationship. Okay. So here you can see that x is increasing and then y is decreasing, right? It's going from 3 back down to 1. And so now our variables are moving in opposite directions. This is what it looks like when two variables are moving in opposite directions, and that's what we call it, a negative or inverse relationship. You can think of a real-life example of two variables that represent or have a negative relationship.
Price of gas and ability to go to the movies. And you're
Right.
paying for more gas, you're paying for less. You can't go to the movies as much.
All right, so when you're paying more for gas, you don't go to the movies as much, or you don't go traveling as much, right, with road trips. You might still have to go to work and school, but anything you don't have to do, you might do less of. The number of vaccines that are given, so less sickness. Maybe the number of hours the college student spends partying, and what might go down? Okay, great. So that's another example. I think you all get the idea there too. One thing that I do want to point out, let me just get this up some. You might remember from math class. That's the formula for a line, right? And we've just been talking about x and y and using that in our example. In math class, was x your dependent variable or your independent variable? Yes, I heard independent. In math class, this was your independent variable, and this was your dependent variable, right? Look, just mathematically, y is dependent on what all this stuff is, right? And that's how you're going to solve for y. Usually, we put our independent variable down here. Don't write this down yet. Usually, we put our independent variable in our dependent variable here. But in economics, instead of y and x, we use price and quantity. I'm going to scratch this out and put price. I'm going to scratch this out and put quantity.
And do they still remain the dependent and independent?
Now, this, you've got to think of quantity as being dependent, the dependent variable, on what the price of a product is. If the price of a footlong at Subway, just right down the street, was $5. Okay, how many would you buy for lunch? Maybe one. How many would you buy? Just one. If it was $1, how many people would buy more than one? Okay. If it was 50 cents, you would probably take advantage of that, right? Assuming that you were hungry enough. Think of how I'm asking the question. If the price of a Subway sandwich was blank, how many are you going to buy? So you'll see the quantity of sandwiches that you're going to be buying is dependent on the price. And we're going to assume that the price of a Subway sandwich is determined by the market. And we'll talk more about that in chapter 4. But just have this in your notes. I know usually in math we had independent and dependent on the horizontal and vertical axes respectively. But in economics, we're not going to have x and y. We're going to have price and quantity here. Well, at least in the graphs that we're going to look at in chapter 4. And you just have to remember, price is independent, and if we're talking about demand, this is actually a demand curve that we have up here with this negative relationship. The quantity of sandwiches that you're going to buy, whether t-shirts or books or backpacks, whatever we're going to talk about, is dependent on the price of that item. So think of it that way in economics. Okay, a couple other terms. I'd like for you to have your notes. Ceteris paribus, right? That's a Latin phrase. For those of you who have had macro before, does anyone remember what that means? All else equal. Yes. Good. Yes. All right. When I was asking you about the price of a footlong, going from $5 to $1 to 50 cents, it looked like more and more of you would be willing to buy more at cheaper prices, right? What did we do? We assumed a whole bunch of things stayed the same when I asked you that question. We assumed that you didn't win the lottery, right? And you could hire a gourmet chef. You didn't have to buy Subway anymore. We assumed that you liked Subway and that you would eat more if you had the chance to buy more with your money. We assumed that there wasn't a health scare that came out saying that the tomatoes that Subway sandwich are using have E. coli and people are getting really sick from them. We assumed all that stuff stayed the same, right? So if you see this phrase on a test question, or you should, whenever you see it, it means we're going to pretend that everything else is going to stay the same. And right now, all we're paying attention to is the quantity demanded for your Subway sandwich based on the price. We're going to assume that your taste, your income, all that stuff stays the same. Okay, one other thing I'd like to have in your notes, I'd like you to have your notes, is the difference between a change in demand and a change in quantity demanded. So I'm going to draw this back up here. In Chapter 4, we'll learn that this is actually a demand curve. Remember, it's got that negative relationship between price and quantity. This is actually, if this helps you, this is actually price per unit, per sandwich, if we're talking about Subway sandwiches here. So when I was talking about $5, that was per sandwich, right? So if, let's say, this was $5, and if I surveyed the whole class, let's say that each of you would buy one. There are about 25 of y'all in here. So let's say that if Subway down the street sold Subway sandwiches for $5, that a total of 25 of us would buy one. This is total over here, and this is per sandwich over here. You just have to remember that. And if they decided to put them on sale for $1, let's just pretend that if I were to survey the class, that we would buy 40 sandwiches. Okay, I'm going to name this point A and this point B. I'll shrink that down a little bit so you can see what I'm doing over here. I'm going to draw another demand curve, and we're still talking about Subway sandwiches. Here's our demand curve, which is negatively, there's a negative relationship between price and quantity. Let's suppose that it was medically proven. So it wasn't just Jared's testimony, but it was medically proven that this is the most effective way to lose weight, to be healthy, is to make sure that you eat, if you are going to eat out, you're going to eat Subway sandwiches. All right. So if everybody hears that on the news and believes that, what's going to happen? Okay, people are going to want to eat more Subway sandwiches. Are they going to eat more Subway sandwiches if they're $5 a piece? If they think that this is healthy, this is going to help them lose weight? Yeah. Are they going to eat more Subway sandwiches at $1? Sure. Are they going to eat more Subway sandwiches if they're $10 for a foot long? If they think it's going to help them lose weight, it doesn't matter what the price is going to be. They're going to want to eat more at every price, right? If they really believe that this is going to be healthy. So what's going to happen now? Here, the price changed from $5 to $1. So we moved from point A to point B. Here, something external changed, right? It was a news report. People's, what we call preferences or tastes changed. So at $5, at $1, if people are going to eat more at every price, this is what happens. So I'm going to call that demand 1. I'm going to call the second one demand 2. Now see the difference? Okay, so on the left side, we call this a change in quantity demanded. And it's caused by a change in price. So when something goes on sale, if something's cheaper and you buy more of it, graphically we're just moving from point A to point B. I had Subway sandwiches here, but if I drew another graph, and this was your favorite sports team's jerseys, after they win the NBA championship, right? Everybody's going to want a jersey from that team because it's cool to have one from the winning team. And it's not going to be because it is cheaper that people are going to want the jerseys. It's going to be because it's really cool to have one. And that team just won, and you're really proud of them for being successful. And this is called, when the whole thing shifts out to the right, this is called a change in demand. And it's not caused by a change in price. It's not that the jersey's cheaper or more expensive. It's caused by, for now I'm just going to say something big. For example, income, consumer tastes have changed. Another example might be that we have more people in town, a number of buyers, and we'll look at more examples in chapter 4. But I wanted you to have this in your notes today because this is a concept that students very easily mix up because you look at the terminology, change in quantity demanded and change in demand. I mean, on a multiple choice question, that's going to be really close, right? When you're looking at those two answers. But now you know it's talking about two different things. So in this case, the demand curve shifted out to the right. And we'll learn in chapter 4, it can shift to the left too. And this one, when we're moving to point A to point B, or if we're moving back up to maybe a point C, it's caused by a change in price. That's the only thing that can cause this, change in quantity demanded. All right, and that is the end of the section on the appendix for chapter 2.